In 13.3, we're going to be finding the trig values for any angle. And by any angle, what I'm referring to is, in the previous sections, we were kind of limited as to what angles we could find trig values of. We were finding them based on this triangle, so our angles had to fit inside a triangle. But what if, let's extend this out a little bit. Let's place this triangle, that was awful. Let's place this triangle, that was less awful, on the xy plane and say, well, what if we wanted to find the sine and the cosine and so forth of a bigger angle, bigger than could fit inside of a right triangle? Well, the cool thing here is the way we've made our picture, and here I'm going to put this inside of a circle. Pretend this is a circle. Let's say that there's this point on the circle, and we draw a line between there, between the origin and that point, and we make a triangle out of it. How do we find the sine and the cosine and so forth of this angle? Well, if we draw an angle between here and the horizontal, we can use the sides of this triangle to find the sine and cosine of this little angle, using the negatives when there's negatives. It's kind of the whole deal. So let's say that this point on the circle is at -4, 3. So this side is -4, and this side is 3. Okay, so it's kind of a weird thing for a triangle to have a side that measures -4, but that's how we can grab all this information out of here. So if we can find the sine and cosine based on, and tangent and everything, based on this angle, that'll be the sine and the cosine and tangent of this larger angle, and that'll work for anything. Just as a quick little aside over here, if we had a big angle like this, like that, and we want to know the sine and the cosine and tangent and all that of this one, we could just draw a vertical line up to the horizontal, draw ourselves a triangle again, and this point might be at like 1, -3, and then we could base everything off of this triangle with a side of -3 over here. So back to this one. This x is -4 and this y is 3, and so we're going to find the sine, the cosine, tangent, and all that of this guy right here, which will be the sine, the cosine, tangent of this guy right here. And if we really quickly do the Pythagorean Theorem for these two sides to find the hypotenuse, be 3 squared plus -4 squared equals c squared, 25 equals c squared, so 5 is c. We put 5 right there. So the sine is equal to the opposite of the hypotenuse, that's 3/5. Cosine is equal to adjacent over hypotenuse, -4/5. Tangent is equal to the opposite over adjacent, that's -3/4. And then we'll find the cosecant, that's the reciprocal of the sine, that's 5/3. Then the secant is -5/4 because it's the reciprocal of the cosine, and the cotangent is -4/3. So we found all of the trig values for this big angle, and basically the only kind of a new idea is that they could be possibly negative, whereas in triangles we always just let the triangle have positive valued sides, and so they were always positive. So we were finding we could try and find the trig values of angles that were less than 90. So if this is 0 and this is 90, we could, in the previous sections, find the trig values for all these angles in here. Okay, so let's extend this idea of this circle, and yeah, so let's just draw a circle. We'll put it on the xy plane again. The only thing is that we'll make sure that the radius, so I'll draw a radius over here. Right. Any line that we draw from the origin to the side is called the radius, and we'll make sure that this radius is equal to 1. 1 mile, 1 foot, 1 centimeter, it doesn't matter, it's 1, and then, whatever it is, that's called the unit, 1 unit. And since it's 1 unit in radius, we call this the unit circle. So it's 1 unit in radius. Okay, so we're going to use this to make a handy little tool, actually. A handy tool called the unit circle. Alright, let's call this 45. This is going to be 30 degrees, and this is 60. And of course, we're running out of room up there, so this will be 90. And, I'll just label the radian measure for this one. This could be pi over 6, this could be pi over 4, pi over 3, pi over 2. That's old news, we know about that. So what we want to do is notice something really cool. So what we really want to do, let's say that there's a point on the circle right here. And remember, this is a radius of 1. All these are 1, 1, 1. And let's label the x and y for each of these, and you'll see why that is really handy. So let's start with 30. We'll draw ourselves a little triangle here, and we know then this side is going to be x, and this side is going to be y, x and y. That makes up this triangle. So what is the value of x? Well, we did this in the last section. We wanted to solve for these two unknown values. We could just say that x over 1, an unknown over a known value. This is known to be 1. Well, what do we call that? This is the angle here. So this is the adjacent side over the hypotenuse. That's what we call the cosine of 30 degrees. We also know, this is just x over 1 is just x. We know that the cosine of 30 degrees is root 3 over 2. So x is root 3 over 2, or x is just the value of the cosine of 30. So what would y be? Y over 1, we could do. Y over 1 is the opposite side over the hypotenuse. What do we call that? We call that the sine of theta, or not just theta, not any theta, but 30 degrees. So y is equal to the sine of theta, and the sine of theta is 1/2. So that's 1/2. So what if we were to set up a triangle again for 45? Well, we'd find out that x over 1 is the cosine, and so x would just be whatever the cosine is. And the cosine of 45 is root 2 over 2. And y would be whatever the sine is, and the sine is root 2 over 2 as well. And for 60, x would be the cosine, so the cosine is 1/2, and the sine is root 3 over 2. We can extend this to all the angles on this circle. 90, if we were going to label the x and y for 90, I'm trying to find a place to put this, maybe right here. So let's label the coordinates of this point. Well, it has 0 for x. It doesn't go anywhere in the x direction. It's up on the y-axis. And how far up does it go? Well, it goes all the way from the origin to the edge of the circle, which we call the radius, and the radius is 1. So we can kind of follow this logic backwards and say that the cosine of 90 is 0 and the sine is 1. And let's just fill in a couple more. Let's choose this one right here. And let's say it's 30 degrees away from the horizontal, so that would make this big angle 150. We'll just put that one here, 150 degrees. And we'll label the coordinates of this point. Well, if you remember from the beginning of this video, if you want to find the sine and cosine of this big angle 150, we could just create this small triangle here and use it. Well, this is just exactly the same as this triangle over here. It's got this angle is 30, this angle was 30. So the coordinates are going to be exactly the same as this triangle, only the x over here is negative. So negative root 3 over 2. And positive 1/2, because y is still positive. what if, let's just use this line that we drew earlier, say it's 30 degrees away from the horizontal. So this little triangle that we're going to draw will always draw up to the horizontal. So what is this? This angle here is 60. So we come around to this 60. It's the exact same triangle, has the exact same sides, only for this one. Oh, and we should say what this is. This is going to be 240. And we're going to label this point and say it's, well, it's going to, like we said, it's the same triangle. It's going to be the same sides as this one that has 60, and instead of being a positive x, it'll be a negative x. And instead of a positive y, it'll be a negative y. That doesn't look negative there. Let's try negative there. Negative root 3 over 2. Okay. So, turns out what we've been doing by going around and saying, hey, look, this triangle is the same as this triangle, that's called using a reference angle. And that's what we'll talk about next. So that's the unit circle. It's really useful to fill in and be able to say, once it's all filled in, ask yourself, what's the cosine of 240 again? So you just come over here and you see that this is 240 and the cosine is negative 1/2. Okay, so for those common angles that are multiples of 30, 45, and 60, really multiples of 30, 45, and that's it, multiples of 30 and 45, because that would include multiples of 60 and of 90. But all of those angles are common, and we want to know the sine and cosine of them pretty readily, and that's a good way to make them referenceable. So the idea of a reference angle is a really simple one. We've already really, in making the unit circle, we've talked about it. The reference angle is that angle in the first quadrant that we can take the sine and cosine values from. Like, let's say that this is 315 degrees. So we just want to know the sine, because it's kind of like we're just still filling in the unit circle. We want to know the sine and the cosine of 315 degrees. And of course 315 degrees is like this. Well, if we just remember that we could find this by drawing a triangle and using the sides of this triangle, knowing that this is 1, well, then that would make this angle here between the horizontal, that's the key, between the horizontal and the line that we've drawn here, the radius, that is 45. And we would already have 45 here. We would know the values for 45 are root 2 over 2 and root 2 over 2. So we'd say, oh, I'll reference 45, use its sine and cosine, and make the signs, the positive and negative of it, appropriate for where 315 is. 315 is in the fourth quadrant, and in the fourth quadrant we have positive x and negative y. So positive root 2 over 2, negative root 2 over 2. Okay, so that's a reference angle. A reference angle is an angle in the first quadrant with the same, let's say, sine and cosine of your angle, the angle you're looking at, except for the it's hard because this is sine, but except for the sines, right? This is sine, S-I-N-E, this is sine, S-I-G-N, the sine meaning positive, negative value. Okay, so the reference angle, we just can go back to the first quadrant and say there's an angle in here that has the same values, sine and cosine and tangent and all of those, as this guy down here or this guy over here, only I would just need to change positive to negative for depending on where I am. Here I'd have to change the x to negative. Both of these would be negative x and y would be negative here, x is positive. Okay, so that's reference angle. Okay, so that's it. Thanks for watching.